10th seminar of spring 2014. Today we have Dr. John Anderson, who is actually alumni from here. He did his PhD with Professor Thompson. Those of you who don't know, Dr. Anderson runs his own company. You just heard the story, Tiger Brain. A little side story is that I was doing some Google Scholar search yesterday to find what his dissertation was, or to use in the introduction today, and I typed Anderson Tiger Brain in the Google Scholar, and it came up with some people in China. There is a last name Anderson, apparently a guy who was doing some MRI scan of tiger brain. And I said, that's definitely not our kids seminar. Try that out. You'll actually find an article on MRI scan of tiger brain, Bengal tigers' brains. But anyway, Dr. Anderson has founded his company in 2000, and he has more than 28 years of experience in project management, civil engineering for aviation, does a lot of runway design globally. This talk today is actually about the Shindand airbase, that the runway that he constructed, actually rehabilitated and reconstructed in 2010, and the challenges facing the construction in a military environment and how it has to be an expedited construction and stuff like that. So without further ado, Dr. Anderson.
Thank you. So this talk is not a whole lot of technical, but it's a lot of the fun things that we get into as airfield engineers. And I'll also start off that when you leave here, it doesn't matter if you're an undergrad, master's, or PhD, once somebody in an agency or consulting firm finds out that you know about pavements, you will be labeled as an expert. Now, that's okay, but don't let it go to your head, because that's when you get in trouble. So you have to drop back to your fundamentals, and when they say, oh, this is so-and-so our pavement expert, you just say, well, I know a little bit about it. You let your background and your training do the rest. But there are lots of challenges we face, and you don't always have a computer, you don't always have reference material, you have to know it. That's what you learn here, is you know it. The other aspect is that a lot of times you will find that where you go out, start talking to other people, they will sometimes interrupt you and say, you went to Illinois, didn't you? Because we all talk the same. Okay, the runway Shindand, this is a quick overview. It was 2,800 meters long, built by the Soviets. Our job was to reconstruct the keel and 2,600 meters of it to get it operational for C-130s. Now, not everybody knows where Shindand is, so which is the pointer? The red line.
Yeah, that was the switch. You have to do the switch. Let's just use on the button.
See, I can do asphalt and soils and concrete. All right.
Yeah.
Okay. That was just turn on.
There's a button there.
Okay. Okay, now you got me like, okay. You take me back one or two.
There you go. Did you find the button? No, it's not there. Right here.
Oh, right there. Okay, nice. It doesn't show up on the screen. Anyway, there's Shindand in the middle of Afghanistan. Not too far from Iran, and Pakistan is off to the right. Turkey, Germany, Europe are up to above. This is the air base as it was when I went in there in 2010. A single runway, parallel taxiway, connectors, and the base camp for the Soviets when they were there is over on this side. The village of Shindand is down here. It was a sort of a vacation spot for the Taliban, so we were always on alert. When I got to, you don't just, buy a United Airlines ticket and go on the Shindand. My travels took me eventually to Kabul, where I was picked up, and I stayed in the safe house for about 30 hours. until they could arrange other transportation for me. When you're in a safe house, you know, you get to know the people very well because everybody watches everybody's back. A few weeks ago, you may have read in the paper where a common restaurant that Westerners go to is attacked. Yes, that happens. My marketing person putting this together, he said, but you don't have any pictures of outside. I said, that's right. If I gave the location, there wouldn't be a safe house anymore. So you learn to stay with people. We had special forces in there that were our security in-house, as well as protection outside. From Kabul, from the safe house, we went to Bagram. I got a C-130 Milair flight to Herat. Spent time in Herat and went down to Shindand. Now in Herat, when we landed, we said, where's our next C-130 flight to Shindand? And they said, up there. So we listed. We said, where do we get to stay? And they said, you get to stay, we got the last few bunks in the Spanish Army camp tent. Great. So we spent the night there. That was the digs. Travel only what you can carry. Be prepared to run. Always bring a towel. That towel is a blanket, it's a pillow, it's a tourniquet, it's a sling. Always bring a towel when you travel to these locations. And use your gear on top. Scott, he'd been around traveling, but we had to walk a kilometer on this rocky road to get from the apron to our camp. And yes, there I am in the back of the 130. The guy next to me was a hired private forces security guy. His weapons were next to him. He didn't have body armor, so he didn't wear it. We get to Shindand, and this is the runway. After every C-130 flight that came in, it was technically closed by the U.S. Air Force for operations. The only way we were able to get in there was after every operation, ground crews had to go and walk the airfield to make sure it was still safe due to FOD. When I arrived, they had just finished putting up a perimeter fence 2 weeks prior. So we're still very remote, expeditionary site. We found the nameplate, the stamp on the concrete, so I can always, I guess they do that over there as well as here, the sidewalks. That was out on the runway. Conditions, bomb damage, it had been through several wars. Rapid runway repairs, you never know what you're going to find. You don't know who did all these repairs. So those are items we had to fix. Surface falls, result of the original concrete construction, debris in the joints, pressures build up at the top, blows out the surface. I'm sure many of you have heard about FOD damage, but FOD is what will kill most runways before cracking and other damage. The way the Soviets built it, set up wood forms, they left the wood in place, and they just built it in concrete. Those little chips you can see in other wood forms, items like that, we get, it seems so minor because we don't really have a class on FOD. But FOD will close the runway down. The story I use is that a squad of F-16s left Langley Air Force Base, took off 2 by 2, and in the second batch of 2, one of them ingested a thumbnail-sized chip of concrete. By the time they got to Panama City, the affected engine had vibrated enough, the aircraft self-destructed in air, crashed into a civilian neighborhood, lost the pilot and the plane. That's what was damage in there. So, FOD is very, very serious. When I was at another installation right after 9/11 and the alert siren went off, the F-15s on alert came out, the lead one fought it out because we were there trying to get the taxiway under control to fix it. They fought it out. That alert mission got canceled. They had to call it up from another base. So FOD is a very important issue. That's where the materials come into play. That's what we get here is materials, understanding of materials. And of course, vegetation on the joints. Okay, you're the pavement expert. You have pavement classes. very first question you're going to receive is, where do you want your test pits at? You have to make that decision. Well, you took Professor Thompson's class, you know, if you go to the county soils report, you look at your soil series and you divvy them up based on soil series. Well, USDA hadn't gotten to Afghanistan. Nor didn't have a USGS topo map either. And if I would have done it based upon military guidance, that would have been 46 test pits down the center of a runway, and they said, yeah, well, you're not going to have that, so what's your next choice? Well, you learn to look around you. We were in a valley. Historic valley, water used to flow through, so it was alluvial deposits of historic sands and gravel, so it's variable, but I shouldn't expect near surface bedrock or anything. So I just want to see how much variability did I really have, and was it a bother to me. The other thing is I always like to put my test pits where the aircraft are, and the main gear are. Ones out on the shoulder don't really help a whole lot. So I located them, and I just had to give it a random spacing, alternating on the center line. Within 1 hour of arriving at Shindand, they gave me 1 hour to stow my gear. They shut the runway down, and they said the crew was waiting for it. So here they are cutting the first test pit. We were using local Afghan laborers, and we cut them very slowly. Of course, they brought a saw that wasn't large enough to cut all the way through the concrete. But there is no nation's mint over there, so you deal with what you can. We dug it out. Subgrade for the most part was 4% wet of optimum. The other lesson, pavements always are wetter underneath. Even in a desert condition with 9 inches of rain a year, it will always get wet over time. This stuff, when it came out, it was just molded up like clay. So that was one factor to deal with. We were also operating, and they only closed, the section of the runway we were working on, so we had the 130s coming in above us, bringing in supplies. The white truck on the side was the one they gave me to drive. The reason I know and remember that was mine is because it's on the center line. When you take control of the runway, you park your vehicle on the center line, because I want those pilots to know that there's somebody out there. Okay? It's very important. Testing. We did do about 18 test pits on the runway, just 1 foot by 1 footers, because we had to then close them back up when we were done, open up the airfield for operations again, every night, for every day. They did have, the lab from Herat did have a field CBR device. Yes, we had to fix it. Yes, we had to test it all through the camp to make sure it worked. But we got it up and got it running, so that cut down on my lab time. We also used the infamous DCP. That's right, I asked for it, and they said, yeah, we don't know what to do with it. I do. It only takes 1,000 blows to drive DCP through the 11 inches of asphalt on Windsor Road, even if you do it 4 times. But it works. Quick and good, solid information. In an expeditionary situation, you can use the DCP as design data. I did want to see if I had any concerns down deep. So I dug 1.5 meter test pits off the edge of the runway with the excavator. And we could only go down about that depth because we get refusal. The gravel just got larger and larger. What did I prove? I proved that I had clay, sands, and gravels above that layer. And at depth, I hit hard, large gravel that wouldn't excavate. Didn't have any pockets of peat or muck. Didn't have any bedrock to deal with. So I characterized what I was working with. Quick and easy. And a test pit always allows you to see what's there. Once we did get into the demolition phase, I went ahead and I dug a few out on the runway to make sure there were no more changes. And some of the values you can see our field CBRs, basically 6 to 8 is the number, a couple higher, a couple lower. Lab CBRs, we did send them back to the lab in Herat. It took about 90 days to get all the lab soaked CBRs because you do it by the Corps of Engineer method. You're doing 3 densities, 3 moisture contents, this whole sequence. Nobody has that many molds. And again, you try to explain to them. You do like we do here. You make it in a 6-inch bulb, you do in the Proctor curve, and you punch it with the CBR piston. That concept is so hard to get across to routine labs. And it gives you quick information, and it works. And then you can see our optimum moisture contents on the far right, around 6 or 7. So we're running right of optimum as expected. Military airfields, different than the FAA. I don't know if anybody here has done a military airfield design. But we do light load, medium load, modified heavy, and heavy loads. Each load has a different mixture of traffic. In this case, for a medium load, which is what a supply or logistics base would have, is B-52s, C-17s, and F-15s. C-17 being the primary cargo supply aircraft. The F-15 will be for the fighters that may come in for refueling or to protect the base. And the B-52 is because every once in a while you may get one. Now, how do they come up with that many passes? Easy. That's how many passes it takes for one standard war. Standard war. What is one standard war? One standard war is you have so many targets take so many missions with ordnance for fighters or bombers. There's number of aircraft, you need so many people and so much support logistics. That's where the medium loads come into. It used to be that for every war fighter with a rifle, there were 8 people in the background supporting them. Technology has lowered that number to maybe about 6. This one, yeah. So the final section that I came up with at the ends, the 300-meter ends, where we have the aircraft are stopped and either turning around or at low speeds, they make it thicker, 380. The interior portion of the runway, 300 millimeters concrete. And I brought in a granular base on top of the subgrade. Oh. So now I've been there for 12 days. I've done all that work. When you're over in a war zone, you work at least a 10-hour day, and you work every day of the week. You never stop. Because if you stop, there's nothing to do, and you will start to get like bored or go crazy. So you just keep yourself working, you drop into a work mode, everybody's working. So we're ready for work. I strongly expect that the gentleman on the far right was probably there in 1961 as a boy building that runway the first time. I also suspect that these gentlemen were out helping doing all the runway patching as well after every event. Again, a few weeks before we got there, there didn't used to be a perimeter fence, and so they would come out onto the runway and have motorcycle races on the runway. But in the village, they don't have any power. There's no power. They live in adobe homes that they built. They plant the hay and the wheat by hand, harvest it with sickles. They have shepherds to take care of the goats and the sheep. So we had to get the keel section operational, which, by the way, I had told the Air Force that the outer edges of the keel were in very bad shape, which were the outboard engines of C-17s are. And our mission was to get this runway from C-130s to C-17s so the base could expand. And those outboard engines would pick up fog because a lot of those distresses I showed were out on the outboard side of the keel. But there were people who didn't quite understand pavement engineering that were assigned to this base that argued and didn't want to do that, even though back stateside they were all, just listen to John, he'll take care of you, just do what John says. But other politics got into it. To speed the demolition, this is the rubberization device. You heard Professor Thompson talk about it, I hope. And Mr. Thompson and I did a airfield rubberization where it was actually transformed into granular base in place for the first runway up in Selfridge up in Michigan in '02 or '03. And I've written engineering briefs for the FAA on rubberization. I've got standard specs set up for forward rubberization. So I use it every place I can. We would have been able to upgrade the entire width and length of the runway by rubberizing and building it on top for that same amount of money that they wanted for the keel. But because of that one colonel that didn't understand, she didn't go to Illinois. Everybody else was on board where they get a full width runway, full length for the same money as a keel. So, anti-go construction. You can use any type of rubberizing equipment you want, but you will end up using anti-go to get the job done. Because this is the equipment that works. Nothing else works. I've worked with everything else. It all breaks. It doesn't work. Just use anti-go. So I tell my contractors. And he had this equipment. It was in Herat. He had rubberized several hundred miles through Afghanistan as part of the USAID program. A lot of those people in the safe house I showed, they were actually there working on USAID projects for water supply and roadways in the northern portion of Afghanistan. So we got a hold of George Shinners. He said yes, he'd be willing to, and we knew that this would speed the demolition process.
There's mouse, like the external
Yes.
mouse connected, you can just keep it.
So if you haven't seen one work, doesn't happen. Now the hammer sequencing, is part of the key, and he can control you wanted to fracture it to ease the excavation. Just another picture after it's been rubberized. And that's George Shinners himself. Monday afternoon, I got a phone call on how to remove a 24-inch thick abandoned airfield in Poland, which convert the runway into a truck road. But they had to match grades. I said, well, we can lower the concrete, or we can rubbleize it and move it out, or excavate it. And I said, I don't know if Antigo is near Poland right now. They usually keep equipment in Europe. And they said, well, if Antigo is not available, I'm sure we can find somebody else. And I'm like, okay, you'll learn. You'll listen. Sent George an email. He responded yesterday and said he's working at the Krakow airport right now, rubberizing in Poland. So it all comes together. Wherever you need to be, they can get there. And we are just excavating using a variety of equipment that they could find. Most equipment that goes into Afghanistan never leaves. It ends up eventually being fixed until they can't fix it anymore. I really believe that this dozer was working when they built the runway the first time. But I was surprised it was still working. A little bit of a structural question. You can see this is the existing runway. We had not rubberized it. This was out in the keel section. You can see it was a solid contraction joint. You can see some type of old joint sealant in the top 1.5 to 2 inches. You can see the original crack, but it's all the secondary cracking going on out to the sides. That I'm certain that when the Soviets were running their bombers out of there, that happened. Also, remember the photograph at the beginning with the surface falls? What do you think this might contribute to? Tearing out an old pavement is an excellent way to learn why it was failing and what's going on and what to look for. You really need to pay attention to it. The pavement will tell you what's happened to it. You just have to listen. So now I've been there for 28 days. Design's heavily underway. Construction is starting. Other aspects we had to deal with. The Soviets this was such a crucial base to them that they had well over 10,000 landmines around this base. Stories were that this was the highest concentration of landmines any place in the world. And I really wish this pointer would work. Oh, there, now I got it. See that rock? This is the edge of the runway right here. That rock, those 3 rocks, that rock, those rocks up through here, over here, over here. We didn't have time to clear all the mines. We just located them and put a rock on it and painted it white or blue. We didn't go on little excursions off the runway. And you also hoped that there wasn't a temperature change that it might go off by itself, because once they're so close together, once one goes off, it can just start triggering. I often felt that you could just take a handful of marbles and throw it and hit something. Now, the Army did clear us a path through the minefield to go from the runway back to our camp, as well as a haul road, so we had that. But did not go off the edge of the runway. On the inboard side, between the runway and the parallel taxiway, nobody had cleared back there. So that not only had landmines, but it also had UXO, unexploded ordnance from various battles. And they were just in the process of clearing it. So we had to keep ourselves, I had no desire to go out there. We did have to have the places where we dug our test pits clear, and then we had our very precise path. We just went out, dug it, and came right back in. It was so easy to start walking down through the dirt, not paying attention. Another way they did it also is perfectly straight lines. Just perfectly straight. And you can imagine that if you were invading, you wouldn't know, so you stumble right into it. On another side of the base where there were on the western side where there were hills that were very close where the Taliban could hide behind and stage like a running attack when the Soviets were there. They also didn't have any mines over on this side, but the Taliban was mostly barefoot. All the sparkles outside that fence is broken glass. Hey, it works. It works. This is the EOD crew in the process of clearing and locating. These were actually Afghan Army soldiers doing it under U.S. direction for training. And behind them, you can see this is a wall around the village over there. And then this road here is the road that you would to Herat if you went in that way. This is the way the U.S. forces will do it when they send convoys out. These are the mine detectors, these wheels, series of wheels, they put enough down pressure, they'll find the UEDs and any mines and they'll explode out front of the MRAP. These are MRAPs, the trucks that the UEDs can explode underneath, and the bottom is shaped like a V, very, very heavy armor, so that soldiers inside are protected. Truck may lose a tire, but we didn't kill anybody. So this is, I want one of these. They're gonna be fun. First one in town, I bet. So a very effective way to do it. Placing base course. Now we've all seen motor graders at work, okay? It's very crucial to be watching how everything is working coming off that mold board. That's where segregation happens. If your granular base, I mean, when we do our modeling, and really maybe a little bit old-fashioned here than me, but we're assuming that we have a nice uniform, homogeneous, elastic material. If we segregate it during construction, we don't know what we have. So it's important to watch how it's mixing or coming off the mold board and shaping it. If it gets too dry, it's going to segregate, and we have something different. So you learn to be near the equipment, but not too close. And watch the material. Watch the material. Conventional roller, doing the base course, action. Sand cones. We couldn't get nuclear gauges in the country, obviously. The word nuclear was on the ticket, so we couldn't come in. We had sand cones. The wind was always blowing. Day and night, the wind was always blowing. And so we had to put up little wind blocks so that when they're putting the sand out, it doesn't, blow everywhere. We had two sets of equipment. We said, let's do it twice at a time so we can maybe get a good answer that looks reasonable. So 39 days on site. Everything is moving along, waiting for the batch plant. This is out here, that village. You can see the village wall in the background. And the mine guys were off to the left. And they're out shepherding their sheep. This boy was probably 6 or 8 years old, maybe. I haven't even seen smaller ones. And I took this through the fence, the perimeter fence. I had broken the rule. I stopped. Came up to the fence, and he was begging for anything. Chocolate bar, out of the water, ballpoint pen, anything. And it'd be no problem for me to give him a chocolate bar that we would get from the dining hall or a granola bar or a bottle of water. It'd be no problem at all to do that. Other than, once we start doing that, then the next day he will come up to the fence. And the next day he'll come up to the fence. By the 4th or 5th or 6th day, the UED will be planted. They watch them and target. They do not care who they kill. They can get a U.S. person in it, or they can get the coalition forces in it, they will take them out. So I had to tell them no. About every day they'd yell and start running, but we just kept on going. This is our camp where we stay. Logistical support area. Connex boxes, shipping containers. You see them on the highways all the time. We put them on boats. When they're no longer seaworthy, they get sold to the war effort. Buy one for $2,000. These are really nice places for us to stay. They really work. Outside, you can see this wall over here. I would say back in the Vietnam days, you had sandbags that young GIs had to go up. These are called pesco barriers. They're a fiber cardboard that holds flat with a wire cage in it. Put it up. And you can fill it up with sand, gravel, whatever you have around with the end loader, very quickly make a force protection. 3 feet of sand will stop a 20-millimeter round. So these were double stacked, so we had good protection against weapons fire. And the Constantino wire at the top. And you can see some of the wind was just blowing. This is just a normal day. Temperatures when I was there were 40 degrees when I first arrived and 120 in the shade on my left. Inside, Western conveniences, really nice. Really nice. So it mostly kept the dust out too. It's nice to have. That is not a wood floor. That is shelf paper. It's either that or an old wooden floor from the Connex box. So it's, hey, you can clean it up, you keep it clean. This is the mechanic. Took care of our SUVs. It's interesting. I mean, the U.S. forces, we have certain policies of working with local suppliers. And so one of the suppliers provided the vehicles for us. We said we needed 10 SUVs. So we assumed and budgeted that they would go to one of the port cities, or in Pakistan or Turkey, and buy them with used cars and bring them to us. They probably did that, but these still have current U.S. license plates, tags, current university parking stickers on them. I mean, some of these tags were, they were just issued like 45 days prior to us getting there. So, if anybody's missing a vehicle, I have an idea where it might be. But I was amazed that he had no electrical equipment, but he could keep the cars running, and that was very important. You always wanted to be able to hit the gas pedal and get away if you had to. This was the gardener. Now, I gave up asking why we had a gardener in a war zone in our camp. I kept asking, and they said, well, the company that built the camp for us, they were supposed to provide something else, and they couldn't, so they said they'd make us a garden. No matter who I asked, the story would change a little. I just gave up. But the gentleman with the water bucket, and that was right outside my hooch, first, the same guy, he was there every day, and did a good job. But there was something about him that my instinct said, always be nice to him, always smile, but don't trust him. He was a Taliban spy, and about 6 weeks later, we proved it, caught him, and once we got him outside the gate, we tried to make a run for it, and we were shot. So, always be nice. You never know. Right outside you. Where there's a war, there's always business and money to be made. This is my boob. And he somehow had a license to bring handmade rugs onto the base. And so I actually bought some rugs. There's only a couple $100 for handmade rugs. Some one came from Mazraki Sharif in northern Afghanistan. Another came from Herat. Each took like a year and a half to handmade. $200 worth several thousand back here. But did it and find a way to ship it back to the military post office and pay for it, and it works. So, nice guy. This was the main camp. You can see the tents that the U.S. forces were in. Just leave it at that. We did get to go into, that's where we ate our meals, and with the dining facility, DFAC, we used to call it mess hall. That's where we ate all of our meals. We did everything with U.S. forces. We did get permission that we could go to the Italian side and eat in their DFAC. Now, they didn't have all the variety that we had in ours, but our stuff was like processed food. At the Italian, every night, they only had either a chicken or a fish or pork. They had fresh lettuce because they were much closer, so they could get flights every couple of days from Italy for a supply. And they had this Parmesan cheese. Oh, I put Parmesan cheese on everything. And they had this huge bowl of it. It was so fresh. I have never found anything in the States anywhere close to that. I mean, I put it on everything. We get a soda drink, and it was family-style seating. This table's not a whole lot wider than these. We were packed in there, and of course, the Italian soldiers, they didn't speak English, they didn't speak Italian. But you would all just sit there and try to converse anyway and have a good time. They could bring in beer. Now, there's no refrigeration, so it was warm. You had a choice. Did you want a beer or did you not? And you just could just drink it there, so you'd only have about one, and that was it. You never want to lose control of your senses from those over there. Force protection, the Army did build guardhouses around the perimeter. The colonel in charge of the perimeter protection, for us, he put, these are not Afghan soldiers, these are from someplace else in Africa, can't remember where. They're very good. They did the job. He gave the best soldiers to us to protect us because we were right on the edge of the perimeter fence. And you can see that we had a nice flat killing ground outside. They did let me look through the night vision goggles one night. Better than what you can see in here right now. That stuff is good. It works. What they could not protect against was mortar fire or rockets. And one night we were sitting out in our camp. We had built a barbecue grill, and one of the airfield majors had arranged to have some beef flown in from Germany. So the barbecue, we're all sitting around there, and you do hear the whistles of a mortar coming in. You heard them come in, and one exploded, one didn't. We found where the one that didn't explode had hit the runway, gouged out the concrete, and we couldn't find the ordnance. Because we didn't go off the edge of the runway, so we figured it bounced and went off into the dirt someplace. But, you know, part of the safety training is that if you're hearing it, that means you're still alive, so that's a good thing. You also don't stick your head up to see where it's going. You actually get down low. Because even if it lands, if the next one lands next to you, mortars are designed for people, so they explode up and out. So if you're down low on the ground, the shrapnel will go over you. And then you try to get your senses at where it's coming from and get yourself into a bunker. Soviet junkyard. When we moved in, the Italian engineers, they took the dozers and they pushed all the Soviet hardware into junk piles. Great source of aluminum and steel now. Village water supply. Now, we're civil engineers. You know, we know how to build things. Our industry is about 100, maybe 200 years old at the most. We have transits. You know, we laid out roads through the mountains. You know, we can do, we're smart. We can do this stuff. That little village didn't have any natural water. The nearest water was 10 kilometers away in a mountain range. You can see way off in the upper corner of the left of that. What they did several hundred years ago, as in 3 or more hundred years ago, is they built an underground tunnel about 25 feet underground. Every 100 meters, because our soldiers went and surveyed it, every 100 meters there's a vertical shaft where they dug down using most likely pig stomachs or buckets, and then they went each direction and tunneled by hand to make this underground waterway. And some of them are still open, some we went and put some caps on to keep them protected. But there it is, the water's still flowing. Now, the tempo of attacks on us increased when we brought in the well drilling equipment to drill the water well for the batch plant. And this is only 25 feet deep, and yes, it's good for the village, but we needed much higher flow rates to feed the concrete batch plant as well as for the future use of the base. When that drill rig set up and they started drilling, the villagers thought we were going to steal all their water, so the Taliban started making more attacks until Special Forces goes back out and has leads. Most of U.S. Special Forces are very light, slightly built in, and not all the big guys. They will infiltrate, learn the language, and negotiate. So that's how we got the attacks to slow down for us. But the villagers were afraid we were taking it. We brought the village chief out. He looked and saw that the well was going 2,000 feet deep, well below this, so we were okay. Here's one of the dust storms that happens over there. It's approaching. You see it coming. That's why we all wear the scarves and things. The windows come in. It's no fun. And it's hitting closer. I was trying to get back to my hooch before I was trying to drive through the road through the minefields and you couldn't see. Got back to this one. Only lasts for several hours that day. Sometimes these can last for days or even a month. They can just blow and blow and blow. An Apache crashed one night. He had several missions coming in for refueling. He was just tired, misjudged, and he thought he was near the ground. He was actually 10 feet above. Dropped hard, hit, rolled, nobody hurt. Back to some technical. Concrete mix. ASR is a concern for the U.S. military overseas, so therefore they want it mitigated. We don't have fly ash. It's very hard to come by in the Middle East. Even Germany is the nearest source. So a lot of times silica fume is used. Silica fume is very available. If you have silica fume in the concrete, the workability disappears. It's very harsh to work, So we use the superplasticides, high-range water reducers. We don't use high-range water reducers in the U.S. for airfield paving concrete. Don't do that because it'll shrink up and crack. And within a month to a year, you'll be replacing it. So over there, we had to come up with a mix design that would work for the materials that we had. I look at the gradations because part of the research and work I've been doing for the military over the last 10, 15 years has been optimizing concrete mixes so they don't chip and fall the joints, because that's where our first failures come from. And you may have seen some of this information, but one thing we call is this big box. We know if our combined gradation is within the big box, it can work. We know that if it's outside the big box, it will not work. I've taken it further, and I looked at the percent retained chart, looking for no big peaks or valleys. This wasn't the best, but I looked at the third chart that I really believe in now, and that is the 0.45 power curve. Hey, does this look like an asphalt mix design? Yes. And the specification that I'm now under contract to write with Ford is the green line is the max density line. This is 0.45 power curve. And if we set an upper limit and a lower limit for one size, so if this was an 1.5 inch rod, we set an upper limit with the one size smaller, and the lower limit is the one size larger. If we keep our combined gradation within those two extremes, we won't have any spalling, especially down in this range, very similar to a sand hump in an asphalt mix in the pre-super paved days. This range down here, I found the hard way, is if that hump exceeds the upper limit, you will get spalling before the air crack even begins to paper. You'll get sliver spalling, very small slivers, but just enough to damage an engine. So this is the new guidance that we're preparing. Ray Rollins and I are doing that, and Shiraz is going to participate. I also used this criteria to convince the Navy this is what we use for the high temperature concrete using lightweight aggregates as well. And that guy is. Batch plant, 2 mixers, horizontal shafts, continuous mix. Most of the concrete plants we use here in the States are a central mix. It's a single, maybe 10, 12 cubic meter drum. Not an option over there. These are Turkish-made plants. So we have 2 horizontal shafts. I thought I had a photograph of it. I only had 30 minutes to inspect the plant. Which, by the way, did you know that you're a pavement expert, that you also know everything there is to know about a concrete batch plant? Mm-hmm. Now, Professor Carpenter, he taught us everything about how an asphalt plant works in the asphalt plants. I don't know if you still do that or not. But, you know, all of a sudden you have to be an expert in everything. Okay. But it's, once you start looking for certain things, and it'll work. Steel forms, and setting them, and dowels, traditional airfield design, and construction. Make sure the forms are aligned straight. Dowels are straight. If it doesn't look straight, it isn't straight. You don't need to measure it, because if you measure it, you're going to find the problem. But if it looks straight, you're okay. Concrete can actually handle a little bit of things that you would not measure. And we did, every airfield paving contractor is the world's expert. And they will tell you that. And you listen to them, and you listen to how they talk, because you learned at Illinois what to listen for, to see what language they're using. And you say, that's great. Let's still go ahead and do a test placement before it's even official, just to see what this concrete mix will do in these conditions, when it's 120 degrees during the day and only 100 degrees at night, and you have a 10-mile-an-hour wind blowing. Let's see what it's going to do. And I don't cure it either, just to see how long does it take before the cracking starts to occur. Amazing, all of a sudden we start learning. Okay, let's keep learning. Because it's easier to rip it out when it's just a small area, third the size of this room, and off in the dirt someplace, and try to do it on the runway. Let's walk them through and learn it. And that identified problems with some of the test equipment wasn't right, and they learned their procedures, and it was a benefit. Now this is where I got really excited, because 20 years ago I had to become an expert in concrete paving machines. Okay? And a Birkin machine, a Turkish contractor had bought a brand new one for this job. I was excited, because a Birkin paving equipment is like, okay, this is good. That tells you, A, the contractor is smart, and B, the equipment can do the job. Comes from Germany, it's great equipment. Now, you build the machine to whichever width you're going to be paving. And it takes about 3 days to assemble a machine to whichever width you want, if everything goes well. Over there, it takes like about a week. It's very slow going. And you buy the pieces and parts to build the width. So we had, early on, because this was design build, I had worked with the contractor. He said how he wanted the size he wanted to build a paver to. I designed the job for that to work. We had the paver en route, coming from Germany all the way by truck. It was about 25 clicks from our base. And the only reason we got these pictures is the truck driver was shot, and the backup driver that was with him, he wasn't killed, but he was shot, and he got away and hid. He took the pictures with his phone and called for help later. So we're like, oh man, now what do we do for schedule? And that's the paver. Interesting is that you could have a container box coming with great big generators. Those don't get destroyed like this. Because the generator has resale value. So what they would do, the Taliban does there, is they will go up to the truck driver and tell him, you can either get out and walk away, or you can try to fight and we'll kill you. But either way, we're taking the truck. Drivers would leave, they take the truck, they take it back into a neighboring country, some contractor working for the U.S. forces said, ICE is in order, I need some generators. Guess what? You're too lucky day. They would be resold over and over. So, it's a different market, different world. We had, so after that happened, the mission needs of this base, Air Force picked up another paver, the C-17. We loaded it in, and they flew it in to Iraq, and we couldn't offload it here yet. And an incredibly heavy armored convoy brought it down to us. It was a smaller paver. I had to redo all the joint layouts and redo the designs again to make it work. Start paving. When you do an airfield work, you will learn to live at night, because most of your airfield paving will be done at night due to the heat. So you get accustomed to that. And that is actually the moon up there in the background. The little speckles are actually the dust that was flowing through that the flash on the camera picked up. Key people. Gentleman on the left was the paving foreman. He didn't always want to listen to me until the concrete started cracking, then he started listening to me. I cannot remember his name, but Mr. Ali is the maestro. Right. He's the one who knew how to put the base course together. He's the one who knew how to put the concrete mix together and how to control the batch. Now, Mr. Ali, he didn't speak any English, and I don't speak Turkish. And wherever he went, and he built his lab on site, he brought his equipment in. We had the Corps come in to certify it, but I had looked at all the equipment anyway, and we couldn't wait for the Corps, so I said, can you just bring through and look at it? Because remember, I'm a paving expert now, because I've been here, so I had become a lab certification expert. And he always travels with a parakeet. So in his lab, out there, he has a little parakeet in it. But he knew exactly what he was doing. I was very impressed. You always build that relationship. And I left him a flashlight and a Stanley 12 meter measuring tape that he bought from Home Depot. To him, that was like, wow. Little things. Curing, moving along. And finally, our first C-17 arrives. This base now has 2 runways, variety of mission activities. We're still, Tiger Brain is still working there. I'm still doing projects there. And even though we are pulling out of Afghanistan, Shindand is still going to remain one of the operational facilities. Activities there. So, not too technical, different viewpoints, a little bit different than Central Illinois. Any questions?
Where did you get Badger Juice, John?
Yes, they came locally being about 5 kilometers away in a dry riverbed, just gravel. When I was in Baghdad in 2009 doing the same thing, there the aggregates, the nearest source of aggregates was about 80 kilometers away, way back into the red zone. And my introduction there was I went to the batch plant operator, Mr. O'Muir, from 77 Construction, because he and his brother graduated from the U.S. in 1977. And I said, I need to know where you're buying your aggregates. And he told me the River Valley Dirt Trucks. I said, okay, well, I need to know that what you're ordering, that they're delivering the same thing every day. So can you show me your purchase order? Mr. O'Muir goes, well, no, Mr. John, I can't do that. Okay. Can you show me your fax, what you're faxing? Oh, Mr. John, I can't show you. I said, well, can you show me the quote that the guy gave you when you did the job, so at least I have an idea? Oh, Mr. John, I can't show you that. I knew that this wasn't top secret stuff. I said, well, what can you show me? He says, Mr. John, when you went to place concrete, then the day before, I get the truck drivers together. I give them cash. They chew in a truck, they drive up there, and they sleep outside the gate at this gravel pit. In the morning, when they open the gravel pit, they go in, the gravel pit puts whatever they want on the trucks. They then come back, and we bring it here to the yard, and that's when you see it. Now, we do get some general classifications, and so that's what we get. The trucks would arrive, it's back, water would still be flowing out the back. That was a good thing, because I had very limited mixed water and no water available for cooling the concrete. So there we would only make concrete in the morning when the trucks would arrive, get a moisture content, and to the batch plant and make it. He said he only lost on average one truck driver a week would be killed. Yes, I can give a little more stories. Any other questions? Yes.
What did you learn from that test placement that you did? Was the mix okay?
Yes, it was. The first one that we did, before we had the paver, the batch plant had just been set up. Yes, they had done their best to balance the scales and everything. But there's always a bug in the plant. It doesn't matter if it's brand new, it doesn't matter if it was just working perfectly from the last job and we just brought it here. There's always going to be a bug, so you find those bugs, get those worked out. Then you look at the workability. We knew we were going to be side forming, we did have a paver, but we worked at how well it consolidates. When you hit the concrete with the vibrator, it should make this nice shiny ring very quickly. The wider the ring is, the more workable, the better consolidation will get. Concrete likes its consolidation. We then learned, and from that day, we did make some adjustments to the mix because we saw how hard the men were working. We looked at what they do at the edges of the form. Because if they're doing it, where they're really working a handful at the corners, they're doing that because the concrete didn't have enough paste there already, didn't flow to that corner, it wasn't workable enough. And when they're doing it with the float, they're bringing up paste, and that is what chips and makes the slippage balls, which goes back to the 0.45 power curve. If you get the mix designed right, it will touch it once and you're done. We also learned how long that concrete could sit in a wide, flat area, no curing on it, no wind protection, before plastic shrinkage cracking would occur. It took several hours for it. That's what we're looking for. Answer your question?
Did you do like saw cutting and stuff, or was it all the forms that you were constructing?
No, originally we were going to pave 2 lanes wide, and they were saw cut the longitudinal and the transverse joints. The second paver wasn't big enough to do that because it had to fit in the back of the C-17, so we paved it only 3 to 4 meters wide, and then we just saw cut it in the squares all the way down.
And the longitudinal was a construction connect with that.
Yes.
Does the existing page down? You don't know?
I did find some 3/4 inch diameter steel dowels in it. Now, they were about a meter apart. Not sure what they were doing, and they were in the transverse joints. Usually there was some steel in it, but fatigue, the fatigue curves. Concrete fatigue is when 50% of the slabs have their first crack, correct? That's what we learned, that's what we all our models based on. Never in your life can you ever find a runway with air-filled pavement that is still actively being used with 50% of the slabs having a crack. Because the fog generated from those cracks would be horrific. So there'll be slab replacement programs. I counted every slab and all the distresses in this runway, and 65% of the slabs had a crack. So I finally got my first one. Anything else?
I was wondering, I worked in an airport in Italy, Even in the airport itself, the runway, they were concerned about noise. Was that a concern? Did they check the runway for you?
Underneath the pavement?
Yes, in some areas, which is from the World Second World War.
Well,
The ends of the pavement, that's what I'm saying.
oh, well, Orlando International had that issue. And in fact, a year or two ago, they found some unexploded ordnance in what is now a neighborhood in somebody's backyard. Here again, we only had our cleared routes. We had to anticipate UXO every place. They were just slowly going through the process, and you could see them digging it up. Even unexploded rockets. You know, they were about this big around and that long. Wonder how those things would fly through the air.
What have they done, John, for that fog problem on the outside of the Keel?
They didn't do anything.
Are they?
Well, no, they went through a sweeping program and they tried to patch it, and I explained to them that the amount of debris deep down in those joints, that it was just whatever patching we do is just going to pop itself out. People back here, they wanted to have it done, should have wrote about it. And said, oops, we did too much. Can't turn back now.
Do they usually put like sealant on the joints and stuff?
Yes, we had them seal the joints. I don't think we could get the preformed rubber over there or not. That you know, joint sealants in concrete pavements are very crucial. They don't keep out water, they keep out the debris, which prevents the fall. Preformed neoprene rubber, that works the best. I've seen pavements 20 years old that look brand new at the joints. Silicone works the second best. The hot tars don't waste nothing. Asphalt was not an option for us when the Antigua revitalized the nearby roadway a few years prior. They brought in asphalt cement in 55-gallon drums. They had a portable mix plant, and they would heat it up and do it. The job was large enough they could bring in asphalt, but for us it wasn't large enough to bring in the asphalt work. You use the manufacturer's lubricant / adhesive, so it slides in the joint.
Have any other questions? All right.
Thank you very much.
Thank you. We'll have Bezak Benia present on his PhD and postdoc work on some acoustic emission and other stuff. And the week after, I think it's Yu Chan presenting on discrete element modeling of aggregates. Thank you very much.